Hello! It is so amazing to be here with you guys at Trino Summit Live. Woohoo! So exciting. We have the people, we have the Pokemon, and it's just an awesome experience. I can't even believe we got Commander Bun Bun to clear their schedule and show up and see us, so that's been awesome. As Brian mentioned, my name is Monica, and I am a developer advocate at Starburst. And I think that all of us in this room can agree that Trino is the best way to federate your data between multiple different sources. So what I want to do during our time together is federate data between S3 and MongoDB and analyze some of the Pokemon data to, obviously in theme, so that we can do some analysis, see the Pokemon spawns around us in San Francisco, and build off from there. So if you direct your attention, and just a little call out, we're going to be using Starburst Galaxy since it's the easiest way to get up and running with Trino. So if you direct your attention to the architecture diagram, basically what we're going to be doing is pulling the Pokemon Go data in. We're going to pretend that we're ingesting that data through like a real-time or near real-time source. So pulling that data in, what this is, it is geolocation data. So we'll have the latitude, the longitude, and we'll be able to figure out the coordinates of the Pokemon spawns as well as the encounter information from that. We also have our MongoDB data, which has our static dimension CSV data, which all of the Pokédex information, the stats. I'm sure I don't have to explain any more to all of this room, but all of the Pokemon data here. Spoiler alert, I do have sad news. We will not be able to go outside and group catch the Pokemon together because this data set is fabricated. However, I have put in a request for next year's Trino Summit that we do add that to the agenda. So we'll see if it makes the cut. Yeah, Mandy's listening back there. Okay, so basically what we're going to be doing is building a data lake architecture here with us. So we're going to start with a land table where we're going to basically have all of our raw data set. And then from there, what we're going to do is clean and optimize that data into a more performant org file in our structure table. From there, what we're going to be doing is combining the two data sources, the Pokemon Mongo data and the geolocation data together so that we create one table for our consumers. We don't really want our consumers being able to access that data, so we're also going to put some role-based access control on it just so they can only read that final table location. Okay, so I have to admit, I did this final table, and I really didn't understand what my insights were from it. So because I am partially a visual learner, I did throw it into ThoughtSpot just so we could understand if there was anything cool that we saw, any trends on our Pokemon, or if, what we see around it for the different types, if we could find any legendaries. So we'll look at that as well, just as a little brief insight tacked on to the back. Okay, so I am supposed to, also, we have pulled location coordinates specifically for San Francisco. So let's hope for the best that Google gave me the right coordinates because I am not well versed on my geolocation. So we're going to try that out for the best. Cole, I'm supposed to give you a signal. I think we are ready to go. Oh, you already did it. Wow! Round of applause for Cole, our techie. Okay, so what I want to do here is just show you the okay, this is my biggest claim to fame at Starburst, is I have named my Mongo data set Pokemongo. Yes. Thank you. Brian and I got a big kick out of it. So basically, this is, like I said, my Pokédex. We have all of the information about it, the experience level, the different attributes, and I just wanted to kind of show you this to you so you had an idea of the data that we were using. Now I'm going to migrate over to S3, and I'm going to show you, this is the CSV that we're pretending that's being ingested. Play along. Here we have the identification information, and then we move towards the name, and then the geolocation, the latitude and longitude, and then the encounter information. So that's disappear time and encounter source. So that's just showing you the actual data information. Here is where that CSV is stored. We're pretending this is where it's landing from that ingestion. Okay, so now I'm going to navigate to Starburst Galaxy and we're gonna get going. So the first thing I want to show you is the configurations for both my AWS and my Mongo connection. Like Pokemon Go, I've done my best to try and stay in the Pokemon theme. Apologies if you're offended, but I think they're really funny. So the first one up is AWS Ketchum. That's my connection to AWS. And so basically here what I'm showing you is the access key information. I'm actually using Glue as my metastore. And then I have turned on the creating external tables and writing to external tables connection information. Okay, next we're gonna move to the Pokemon Go instance. And what we're gonna do is just show you that there is just one connection URL. It's very simple to connect. All good here. And then from this, what I've done is built out a cluster connecting these two catalogs together. So I'm gonna migrate over here. My favorite Pokemon of choice when I was actively playing Pokemon Go was Charizard, so I've got that all set up. And here you see the catalogs. I have two different connected, the AWS Ketchum and the Pokemon Go DB. You can also, we have our cloud provider region selected, and then there is also the execution mode. We're not doing anything super intensive, so I left it off, but you do have that option to turn it on if you want. Okay, so now we're gonna navigate to the query editor and we're gonna get started. So the idea of this demo, like I mentioned, is to start with, first we're going to do our land. So we're going to create a Hive table from the CSV and act like this is us creating a land table, the raw table, moving forward from there. So I'm just going to create my schema first. Cute, perfect. And then what I'm going to do is create my Pokemon Spawns landing table. So this is going to have all of that information from the CSV that I showed you. So like I mentioned, the S2 token information, that's the identifier, and then the latitude, longitude, and encounter information. So we're going to run that, and it will be with type Hive, format CSV from my external location that I showed you. There we are, and then I'm just going to select from that data source to show that it works. Here we are, we've got all of our data replicating what was in that CSV file. So now we're going to move on to our structure layer, and we're going to actually be using Iceberg. So shout out to Mark for all of the Iceberg information. We're now going to do ORC files as well, or ORC format as well with our Iceberg. So I'm going to run my second schema. I want all of my Iceberg tables in a different schema, just because that's what I was told to do by my business. So we're going to do it. So here you can see the query information. This is the query that's pulled in from our Pokédex table in MongoDB. We're going to be casting all of our data types to the correct one, and we're going to just grab all of that information and input it into our structure table, or our structure layer. So let me go ahead and run that data. We've got our table created with the right number of rows. It's almost like I've done this demo before to know that's the right number. And here we go. We're going to select from that table. So here we go. This is just a recreation of that MongoDB table, but now here. You can see we have the abilities, all of the statistics for that Pokemon, building off from there. So the next thing I want to do is create my Pokemon spawn structure table. So again, this is going to be removing the some of the information we don't need, specifically the identification information, but we're going to be casting to the correct data type, and then we're also going to be moving the rest of that data over in format ORC with Iceberg. Running, perfect. And now I'm going to select from that source. Here we are, we've got the encounter information without those identification columns present. Okay, so we're gonna make the consume layer now, which is just creating the join between those two structure tables together and testing out my latitude and longitude knowledge to see if I pulled the right thing from Google. So we're gonna be pulling in all of the columns from the from the Pokemon spawn information, and then we're gonna pull over the type 1, type 2, and the legendary status. So I'm gonna run that query now. And then we're gonna see what that final output looks like. So there you go, there you have it. That's that final output where we have all of that information from the spawn table, as well as a type 1, type 2, and legendary status applicable as well to the Pokemon. So I just wanted to show you this really quickly before we switch over to the ThoughtSpot dashboard. We have the ability to set in Starburst Galaxy, we have the ability to set role-based access control. So I mentioned earlier we don't really want the consume layer to have access to update or insert or delete from those tables. So I have, as an account admin, made another role for those users. I'm going to switch to it now and show you that we actually don't have permissions. We can actually query the data, but we don't have any permissions to update it. So when I return this query under the consume layer access role, we'll get an access denied error. There you go. And then I'm just gonna switch back to my account admin and show you that running the query with this row, it'll return 0 rows, but it will indeed run. So just showing you the difference there. Okay, so now we're going to switch over to ThoughtSpot and talk about specifically the information that we've found out from that Pokemon dataset in the consume table. I have to admit, I'm a little bit of a Pokemon noob. I didn't really know very much. I had no idea that you could have different types of Pokemon for the same name. So this graph was really insightful for me to learn. But it does make sense that we have the Zubat as the most popular Pokemon prevalence in the area. So if we scroll down, you can see the Pokemon location data. Originally, the location data, geolocation that we had was in Arizona and New York, as well as all in California. So we did pick the right coordinates, and we were able to zoom in. That's what the graph on the left, your same left, is showing you. And then on the right, what we're seeing is just, where if we had, like I said, a break today or next time we do this, where we could go sit and hang out and, return on investment for our Pokemon swipes of where we wanted to go. And then the last thing I just want to show you is I was really interested in what type of Pokemon were the most prevalent from that data set. Obviously, I included water in my geolocation, so it only makes sense that water was the most popular type of Pokemon. And then if we are to dig into both type 1 and type 2, you can see again the water being the most popular for type 1 with a null type 2, but you also have flying being super popular. Look at this little group over here, and you can have both with normal and poison Pokemon for type 1. I learned so much when I was Googling all about Pokemon, so really appreciate us having a Pokemon theme. And then I'm just going to drill down and look, because this just makes sense, that there will be the most popular water, Magikarp, which I do remember from my Pokemon Go days. So thank you guys so much for having me. I appreciate you guys letting me be up here and kind of show you this little demo, but I hope the rest of the afternoon continues to be awesome. So thanks.